Hi everyone, welcome to session 6 of our course Quantitative Methods in Management. Happy learning to all of you. Now in the last session we had seen what are the elements of OR formulation. So basically three elements we have studied, which are identification of decision variables and then formulation of the objective function for the problem and formulation of constraints for the problem. So with that we have seen what is the standard format for formulation of a linear programming problem, and we had also solved one problem on formulation of a linear programming problem. Now we'll move on to, hope you remember that cement industry problem which we had solved. Now in today's session we will see some more examples related to formulation problems. Okay, we'll get back to the business today. So to have a recap of what is standard formulation of linear programming problem, we have seen that we are expressing the objective function which we need to optimize in the form of maximization or minimization of the objective function. Maximization will come when it is relating to profit or gain or say benefit and so on, and minimization will come when it is relating to cost or time or loss, which is equal to C1 x1 plus C2 x2 plus C3 x3 etc. up to Cn xn, where x1 x2 x3 up to xn indicates the decision variables in the problem, and C1 C2 C3 etc. up to Cn indicate the unit cost or unit profit as the case may be. This objective function is valid when it is satisfying the constraints in the problem, which are represented as equations of the decision variables. So which are represented like this, and each will be taking any of these inequalities. That is, either it can be in the form of less than equal to or greater than equal to or equal to b1, b2, so on up to bn. So each of the constraints will have to satisfy the restriction in the problem, where b1, b2, b3 etc. indicate the available resources or required resources, and the sign of the decision variables are always non-negative. So that is the expressed by this particular constraint equation. So let's get started. So today we will see the second exercise on formulation of a linear programming problem. Now let me read out the problem for you. A firm produces 3 products. These products are processed on 3 different machines. The time required to manufacture 1 unit of each of the products and the daily capacity of the 3 machines is given in the table below. So last problem we had formulated or extracted the table or extracted the data from the problem, which was in the form of statement, into a tabulation form. In this problem already the table is given to us. So here in the table it says there are 3 types of machines, M1, M2, M3, and 3 products to be made, product 1, product 2 and product 3, and the requirement of each of the machines for making 1 unit of each of the products is given here in terms of minutes. Like you can see the first cell, which shows product 1 would require 2 units of 2 units, here it indicates minutes, 2 minutes of processing on machine 1, 4 minutes of processing on machine 2 and 2 minutes of processing on machine 3. Similarly, product 2 would require 8 minutes of processing on machine 1, no processing on machine 2 and 5 minutes of processing on machine 3. Similarly, product 3 would require 2 minutes of processing on machine 1, 8 minutes of processing on machine 2 and no requirement with respect to machine 3. And then they have also given what is the maximum capacity of each of the machines in minutes per day. That is, maximum capacity of machine M1 is 940 minutes per day. For machine M2 it is 970 minutes per day, and machine M3 it is 430 minutes per day. Now we'll continue the problem. It is required to determine the daily number of units to be manufactured for each product. So this is the question, that is the requirement, which is indicating the hint for the decision variables. Okay, so it is required to determine the daily number of units to be manufactured for each product. That is, number of units of product 1, how many numbers you want to manufacture per day, how many numbers of product 2 to be manufactured per day, and number of units of product 3 to be manufactured per day, and the profit per unit of each of the products, product 1, 2 and 3, are given as rupees 4, rupees 8 and rupees 6 respectively. That is, by selling product 1 unit of product 1, the profit of 4 rupees can be obtained. Similarly, by selling one number of product 2, rupees 8 can be obtained. By selling one number of product 3, rupees 6 can be obtained. It is assumed that all the amounts produced are consumed in the market. What does it mean? This statement is explicitly told here in this particular problem, meaning that whatever is being consumed or whatever is being produced, it is totally sold in the market without being any of the products not getting sold. So that is the understanding of this. So whatever is being produced, let us say x1, x2 and x3 of product 1, product 2 and product 3 are being produced per day. All are being sold in the market. So that is the understanding here. So formulate the linear programming model for the problem. So first, from this table, it is very clear that we have three decision variables, x1, x2 and x3. So I have told you already that identification of decision variable can be obtained from knowing whether you are going to find out the unit profit or unit loss. So here it is given as profit per unit of each of the products are given to us. Therefore, so product 1 is number of units of product 1 to be manufactured per day will be x1. Number of units of product 2 to be manufactured per day would be x2. Number of units of product 3 to be manufactured per day would be x3. So three decision variables we are having in the problem. Okay. Now what is the objective function? Objective function is by selling x1 units of product 1, x2 units of product 2 and x3 units of product 3, we should be able to derive maximum profit for the company. So that is the objective, and we know that 1 unit of product 1 is sold at a price or a profit of rupees 4, and per unit of product 2 is sold at a profit of rupees 8, and per unit of product 3 is sold at a profit of rupees 6. Therefore, we can find out what will be the product with respect to x1, x2 and x3 total profit. So that is going to be the objective function. And with respect to the number of constraints, we have here three number of constraints, each with reference to the requirement of machine 1, 2 and 3 and what is its available capacity per day. So let's go back to the formulation part. So here we say, as we have discussed, step 1 is to identify the decision variables in the problem. So we have seen from the problem that the company is interested to know how many number of units of product 1 to be manufactured per day, how many number of units of product 2 to be manufactured per day, which is x2, and how many number of units of product 3 to be manufactured per day, which is x3. So x1, x2 and x3 are the decision variables whose sign will be greater than or equal to 0, because the number of units of any of these products can never be negative. So it cannot be less than or equal to 0. It can be only greater than or equal to 0. So these are the three decision variables in the problem. Now we'll move on to the objective function. So objective function is to maximize the total profit coming from selling x1 units of product 1, x2 units of product 2 and x3 units of product 3. So we already saw that x1 is relating to product 1 manufactured per day, number of units of that. So, and we have also seen in the problem that by selling one number of product 1, we are able to get a profit of 4 units. And we are going to manufacture x1 number of product 1. So therefore, total profit would be 4 into x1. Similarly, by selling 1 unit of product 2, we are able to get a profit of rupees 8, and the number of units that we are going to produce with respect to product 2 is x2 numbers of unit per day. Therefore, the total profit from x2 will be 8 into x2. Similarly, number of units of product 3 manufactured per day is x3, and 1 unit sold of product 3 will produce a profit of rupees 6. Therefore, total profit from x3 units will be 6 into x3. So, summing up of all these three will be the total profit, and we want to maximize that. So, that is the second step, which is formulation of the objective function, which is maximization of total profit. So, Z here is indicating total profit, which is equal to 4x1 plus 3x2 plus 6x3. So, 4 is, by selling 1 unit of product 1, I am able to get a profit of 4, and we are going to manufacture x1 units. So, total profit is 4x1. Similarly, with respect to product 2 and product 3. So, this is our objective function. Next, moving on to the constraints, we have restriction on 3 types of machines: machine 1, machine 2 and machine 3. So, whose requirement with respect to each of the products are given to us in the table. So, we can see that with respect to machine 1, product 1 unit of product 1 will require 2 minutes of machine time M1, and 1 unit of product 2 will require 8 minutes. 1 unit of product 3 will require 2 minutes. So, we are going to manufacture per day x1 units of product 1, x2 units of product 2 and x3 units of product 3. So, the total requirement of machine time with respect to machine M1 is 2 into x1 plus 8 into x2 plus 2 into x3, which should be satisfying the available resource, which is 940 minutes per day. So, this is the total machine time M1 availability, which is 940 minutes per day. That means 2x1 plus 8x2 plus 2x3 should be less than or equal to 940. So, whatever we produce with respect to each of these 3 products should satisfy the total available machine time M1, which is 940 minutes. So, that can be the appropriate inequality sign will be less than equal to only here. So, we can see the function has been written here: 2x1 plus 3x2 plus 2x3 less than equal to 440 minutes. Similarly, with respect to machine 2, we are having the requirement for product 1 and product 3 only. Product 2 does not require machine 2. So, therefore, 1 unit of product 1 requires 4 minutes of machine time M2. So, total number of units of product 1 to be manufactured per day is x1. Therefore, the requirement will be 4 into x1 plus 0 into x2 plus 8 into x3 should be less than equal to 970. So, that is what is shown in this case. 4x1 plus 0x2 plus 3x3 is less than equal to 440. Similarly, with respect to machine 3, it is 2x1 plus 5x2 plus 0x3 less than equal to 430. So, that is what is given here: 2x1 plus 5x2 plus 0x3 less than equal to 430. Finally, we have x1, x2, x3 greater than equal to 0. So, this is the standard formulation of the problem, which is exercise 2. Hope students, you have understood this problem. Next, we shall see this problem. So, you are going to try out this problem. So, I'll just read out this. A person wants to decide the constituents of a diet which will fulfill his daily requirement of protein, fats and carbohydrates at minimum cost. That is, he wants to identify, a patient wants to identify, or a person wants to identify how much he has to consume, okay, such that his protein, fat and carbohydrates are getting fulfilled, and it was also at a minimum cost. And the choice is to be made from 4 different foodstuffs, and the yield per unit of these foods are given in table. So, we can see here food 1, 2, 3, 4 are given, food type 1, 2, 3, 4 are given, and these are the requirement for the patients: protein, fat and carbohydrates. Their requirement in the food per unit is given, and what is the cost is given to us, and what is the minimum requirement of each of these protein, fat and carbohydrate is given to us. So, please formulate this as a linear programming problem. Thank you, students. We'll see you in the next class.